welcome to this week's Two Dudes Talking About Science. This week we have on tap for you a pretty good show. We're going to be talking about the PETM, Paleocene Eocene Thermal Maximum. We got Justin in the studio as well.
Yo.
Let's go. Let's give you some basic information about the PETM. What is it? What is it? Justin, can you tell us a little bit about what it is?
Yeah, the PETM occurred about 55 million years ago, and it's a really important time period because when continents began to drift, volcanoes, methane hydrates were released, there were fires melting, permafrost melted, and this had pretty significant impact on the world. Anish?
Yeah, there were around, the CO2 emission rate at the time was around 5 billion tons per year. Let that sink in for a little bit. Oceans were acidifying, wildfires, as Justin mentioned. There was coral bleaching. It was just a time of massive change for the planet. And
the main effect was like a gradual warming of the world with significant effects. So we're gonna
we'll get into that a little bit. We got a caller here who's talking a little bit about space. I guess I don't know. That's what the producers are telling me. So.
Ring.
Hello. Who is this?
Hi, this is JB. Thanks for having me on the show. It's a pleasure to be here. It sounds like we have a lot of great things to talk about today. You know, I went to the doctor earlier this week, and as you may know, I'm pretty anal about getting there early. So I'm sitting in the waiting room because I was early, and they were running behind, of course, and I noticed Nature magazine from 2005. I'm thinking, you should really update your magazine collection. It's 2015. Anyway, I started skimming the mag, and I noticed an article titled Astronomical Pacing of the Late Paleocene to Early Eocene Global Warming Events, written by Lucas and his team. I'm thinking, what a mouthful, but in it I noticed the word Elmo, which, as you may know, I'm a diehard Sesame Street fan, so I decided to read it. Unfortunately, this was no article about the show. Instead, it proposed an alternate explanation to the reason that the world had warmed up so much during the Paleocene-Eocene epoch 55 million years ago. It acknowledged that the driving belief that the world had warmed up so much was due to a large dissociation of methane from the ocean clathrates causing severe carbonate dissolution in marine sediments. They explained that the orbital forcing has been generally excluded. I had just seen Interstellar, so the talk of space having such a large impact got me pretty excited. It turns out that the Earth's eccentricity cycle, which is the orbit around the sun, times up perfectly with the release of methane. They believe that a certain position along the Earth's eccentricity cycle caused extreme seasonal contrast at both hemispheres, which caused the seawater temperatures to increase, which then triggered the release of oceanic methane hydrates. These cycles and the long-term late Paleocene to early Eocene warming trend may have favored the buildup of significant methane hydrate reservoir before it's released. So you're probably wondering, Anish, where the Elmo and Sesame Street come into play.
I was hooked on the Elmo part, so yeah.
Well, rest assured. Well, actually, not really. They're actually talking about the Elmo horizon, which was a second warming period after the PETM that also coordinates with astronomical timing. They believe that the less extreme signal of Elmo compared to the PETM may reflect the inability of the methane hydrate reservoir to return to pre-PETM dimensions, especially under the warm conditions that prevailed in the early intervals spanning the two events. Can you believe that they were able to get all of that from just drilling into the ocean floor to get deep sea cores and then examining the distinct carbonate pore clay layers and then syncing this up with the Earth's orbit?
I could never imagine that. That's truly moving research nowadays. I also saw Interstellar, which is a great movie, by the way.
Matthew McConaughey really killed it.
Great job there. So on another note, I'm trying to move from New York to Seattle, and it's been pretty stressful. So I was also reading Nature magazine a couple of weeks ago, and there was an article about like primate biogeography by Christopher Beard on a topic of primates in North America. So it's pretty cool, actually. So research has shown that primates came from Asia and Europe to North America during the PETM due to the fallen sea levels, which was I knew that part. But going on that, they focused on a specific species of Taillardia, which is a marmoset type monkey, and it's believed to be the oldest member of its genus in North America. And what they had said was, based on research they had done among fossil plants in different levels of the earth, it showed that primates generally lived in coastal areas during the beginning of the PETM, and after the drop in sea levels, moved to different environments that they couldn't reach before, such as the Rocky Mountains, due to the water levels surrounding it. And I thought that was pretty interesting. I hope the water levels sink enough so that I can make the move to Seattle. But
yeah, maybe they'll get back to the Super Bowl again.
Yeah, exactly.
Because we know New York won't.
Yeah. Okay. Oh, too soon. All right, we have a caller here.
Ring. Ring.
Says it's Harry Potter.
Ring.
But, okay, let's go to Harry, I guess.
Hello, Muggles. Thanks for taking my call. Boy, it's weird using a telephone. I would have sent Hedwig, but your show isn't owl-friendly.
No problem, Harry. Thanks for calling. What do you want to talk about?
I was listening to your show while I was drinking some butter beer, and I think that I may have a problem that you may be able to shed some light on. We have a snake issue on campus, and the problem is that the snake is gigantic, similar to Tanaboa that we discussed last week in the show. How do you think this happened?
Well, the answer to this seems pretty simple to me. It seems like the giant snake on your campus found some port key in the PETM and was transferred to the school. You see, the PETM reptiles are able to grow gargantuan sizes due to the warmer climate.
Well, that makes a lot of sense. Okay, well, I have to get going. Ron and I have some shenanigans to get into before my big Quidditch match against Slytherin. Thanks, mates.
Thanks, Harry. That was a very interesting caller. I think you've noticed we've had some interesting callers the last couple of weeks.
Yeah, we had a good draw.
Yeah. I think there's someone named Nick who's trying to talk to us. Hello?
Hey, how's it going?
Hey, so tell us, Nick, Professor Nick, how do we know the PETM was a global phenomenon?
Well, Justin, we're able to analyze oxygen ratios in ancient foraminifer fossils that allow us to conclude that oceanic surface temperatures were 7 to 9 degrees warmer at the poles and 4 to 5 degrees warmer in the tropics.
Whoa there. Those are a lot of sciencey terms.
Yeah, I'm sorry, let me explain a little further. So foraminifera are these little organisms with calcite shells, and each of these shells has a certain amount of carbon-14 and a certain amount of carbon-12. The ratio of C14 to C12 depends on the oceanic temperatures. And so when these foraminifera die, they sink to the ocean floor, but their shells remain intact. And over time, these shells build up on top of each other and turn into these big cores that scientists are able to drill out of the ocean and analyze.
That sounds pretty thrilling stuff. What does this have to do, though, with the PETM?
Yes, it is thrilling indeed. Essentially, this is important because oxygen isotope ratios in foraminifera shells prove that the conditions in the PETM were very similar to conditions today. We knew for quite a while that there was warming at the poles during the PETM, but it took us a while to prove that that same warming was also occurring at the tropics during this time.
Oh, okay. Why is that?
Well, for a while it was pretty difficult to find foraminiferous samples in the tropics. However, in 2003, a team led by Zakos finally found suitable foraminifera cores. Testing confirmed that there was warming at the poles as well, or at the tropics as well, which confirmed that the PETM was indeed a global phenomenon.
Wow, somebody call Nelly. Things are getting pretty hot in here.
You could say that. This was also important because these results necessitate a rise in atmospheric CO2 that was 3 to 4 times more than previously estimated. What this means is that scientists who use computer models to analyze climate change had to readjust all of their models, which in turn resulted in very different outcomes.
Wow, that's really fascinating. Thank you for sharing.
Hey, thanks for having me.
Hello, it's Professor Smith. Can you hear me?
Yes, Mr. Smith, we can get you.
Okay, I'm calling from Patagonia. I'm here working on a study of fish contamination due to the massive increase in commercial fishing. But since you were talking about the PETM, I read an article recently that was pretty interesting. It was about Wyoming. Is that in the United States?
Yes, it is.
Okay, so these two people, Mary Kress and Susan Riggins, delved into the idea that the PETM had rainfall implications in terms of, due to the increase in temperature, there was a decrease in rainfall. So Krauss and Riggins looked into the paleosoils, or basically fossilized soil, which had been buried under newer soil, and by analyzing the colors, nodule types, and grain sizes, they did more research on the mineralogy of the soil, and they determined there was a significant decrease in rainfall during the PETM, which I thought was pretty interesting because this was confirmed through the unearthing of old soil and analyzing that in comparison to soil from other periods, which I thought it was pretty interesting.
Yeah, it is. It is very interesting. But I'm gonna have to cut you off there. It appears we're getting a call. It looks like we're in for a treat right now, ladies and gentlemen. We have a bona fide celebrity in the house today. Here's the man with the most beautiful voice in the world, Sebastian the Crab from The Little Mermaid. Sebastian, you seem to be breathing pretty heavily, my friend. Is everything all right?
No, it is not okay. Everything is wrong. The world is not a safe place for crabs or any animal with a calcite shell anymore.
Whoa, that's a pretty lofty statement. Why do you say that? I think it's pretty fair to say we love crabs, especially after your performance in The Little Mermaid.
I just read a paper by the famous environmentalist Zakos. As we all know, the climate today is moving towards a climate just like the one during the PETM. The paper I read says that there was a massive extinction of marine animals with calcite shells due to oceanic acidification.
I'm really sorry to hear that, Sebastian. That sounds terrible.
Yes, indeed. Theoretically, oxidation and ocean absorption of carbon dioxide should have lower deep-sea pH, triggering rapid shoaling of the calcite composition. What this means is that crabs like me are having our shells melted. Scientists prove this by looking at layers of clay between 2.7 and 4.8 kilometers deep into the ocean.
Well, it sounds like it's not going to be better down where it's wetter pretty soon.
All right, I think we gotta pay some bills here at Vanderbilt. So we're gonna go to a commercial.
Hi, are you a baby? Are you sick of riding a boring stick horse? Regular horses too big for your baby bodies? Well, to all you cowboy babies out there, Baby Horses Incorporated has some great news for you. Thanks to our eggheads in the lab, we've developed a time machine to take us back to the PETM, where we've grabbed a number of tiny horses. You'll be the hottest baby on the playground pulling up to preschool on your trusty steed. Your other baby friends want to be you, while girl babies want to be with you. So saddle up and pick up your tiny horse today, partner.
Wow, these commercials just keep getting better and better. But yeah, Justin, you had a little segment that you're gonna close out the show with.
Yeah, everyone knows that every rose has its thorn, thanks to Poison and Bret Michaels. They're an American hero. Well, I wonder if he'd be singing that song if we dropped him back in time during the PETM. The evidence for vertebrate changes has been pretty well discussed already in the show, but now we are starting to get more evidence courtesy of Wing and his team in Science magazine in their article, Transient Floral Change and Rapid Global Warming at the Paleocene Eocene Boundary. They found that the global warming of 5 to 10 degrees Celsius caused floral composition changes as evidenced by plant fossils discovered in Wyoming, showing that PETM floras were a mixture of several new species that had migrated into the region and the current ones, both from Europe, from southern North America. They believe that the warming during the PETM facilitated these migrations, allowing plant species to adapt to warmer climates and expand their ranges. The PETM provides an important equivalent to today's present global warming. And even though they were not getting the glamour of studying dinosaur fossils, the plant fossils they found have way more relevance to today's world. And I guess that really leaves us with the overarching theme for today. We can look back in time to examine what may happen in the future, thanks to the similar global warming trends that we saw in the PETM.
Yeah, that's a very, very scary and sobering thought in terms of the rate at which we're burning fossil fuels and destroying the earth is leading to CO2 emissions at a rate of 30 billion tons per year. Which what was the one for the PETM?
It was about 5 billion
so
tons.
We're doing around 6 times the amount of damage, and the rate of warming is increased to 1 to 4 degrees Celsius increase per 100 years, which is which is just so much bigger than it was prior. And I don't know, Justin, you had any more thoughts?
Yeah, I think the planet's on a crash course, and if changes aren't made soon, we're going to notice pretty big changes to the world, negative ones. So thank you for joining us.
We'll be back next week with our KT Extinction podcast. So
have a great day.